Hey everyone, so in this video we are going to see how we can scale up our previous method of using augmented matrices to solve a system of two linear equations in two variables. Let's see how we can now scale this up to attack solving a system of three linear equations in three variables, which is given here. So the system of equations I want to take a look at is x1 plus x2 plus x3 is equal to 7. x1 minus x2 plus 2x3 is equal to 7, and then 5x1 plus x2 plus x3 is equal to 11. So the first step would be, let's set up our augmented matrix for this system. So the first column is 1, 1, 5, 1, minus 1, 1 for the second column, and so on. So you can verify that we would have the following augmented matrix that we would start working with. And so a reasonable first step might be, well, let's eliminate the x1 in this equation by multiplying the top equation by minus 1 and adding it to the second equation. So in other words, we're going to replace the second row in this matrix with minus 1 times row 1 added to row 2. So I'm going to multiply everything in the top row by minus 1 and then add it down below. And so that's going to result in a new augmented matrix, which I've written out here. So the minus 1 and the 1 cancel. This gives me minus 2. Minus 1 plus 2 gives me a 1. And then we get the minus 7 plus 7, which cancels out and gives me 0. And then let's do the same thing again, similar thing again, where now we're going to multiply this top row, let's say, by minus 5, and add it to now row 3 so that we can eliminate the coefficient in front of the x1. And after performing that operation on this matrix, we would now have minus 5 plus 5, that gives us 0. We have minus 5 plus 1, that gives us minus 4. Minus 5 plus 1 gives us minus 4 again. Minus 5 times 7 is minus 35, and then we add a positive 11, and that gives me minus 24. And now let's repeat a similar process, and that is, let's eliminate the minus 4 in the last row by replacing the last row with minus 2 times the second row. So if I take minus 2 times the minus 2 here, they are going to cancel off, and I will have a 0 in that place in the last row. And continuing this along with the other ones, minus 2 times 1 minus 4 gives us minus 6. Minus 2 times 0 minus 24 gives us minus 24. So now we've eliminated the coefficient beneath this one over here. Next, let's scale this last row so that we have 1 as the coefficient corresponding to the third column. So I'm going to divide this last row now by minus 6. So from this last row, as in with the case with two equations, I can see that variable x3 solution is going to be that it is going to have to equal 4. And we want to get a similar equation so that we can easily see what x2 would be, and we can easily see what x1 would be. So now that I have my row 3 as 0, 0, 1, 4, I can now work my way back up. So I can use this row to eliminate the 1 in the row above by, say, let's multiply row 3 by minus 1 and add it to row 2. And with that operation, that's going to kill off the 1 here. But when I multiply this by minus 1 and add it to the second row, I'm going to get a minus 4 in that last column. And now we have a nice way of reading off what the value for x2 would be, but let's scale this down as well. Let's take each of these entries in this row and divide it by minus 2. And that results in a second row, which is now 0, 1, 0. When we divide that by minus 2, we get a 2 over here. So far we can see the solution is going to have x3 is going to equal 4, x2 is going to equal 2. And let's figure out what we would get for x1. And in order to do so, let's eliminate the 1 over here and the 1 over here, so we can get a similar way of easily reading off what the value for x1 would be for this solution. So we can first kill off this 1 by multiplying, say, row 2 by -1 and adding it to the top row. And that is going to give us now the -1 plus the +1. That gives us a 0 over here. This has no effect on this entry over here. And when I take -1 times 2 and add it to the 7, what I get left over is 5. And now let's do this one more time to get rid of this one over here. And in order to do that, we are going to need to use this last row over here. So now we're going to multiply row 3 by -1 and add that to the top row. And that's going to give us now -1 times 1 added to this gives us a 0. I get -1 times 4 added to 5. And what's left over is a 1. So now I can see my solution from this augmented matrix, which is the solution is going to be x1 should equal 1. x2 needs to equal 2, x3 is going to equal 4, and we can see here this system of 3 linear equations in variables x1, x2, and x3 has one unique solution.